Dear faculty member, this is me, Nugroho. I want to present my homework 3, number 4, with the topic of servo motors. It comes from the Arduino book, example 3.11, and we have RC, servo motor, and a potentiometer and LCD. The hardware that I use, one Arduino Uno, one micro servo SG90, one LCD 16 by 2, and one I2C2 LCD, and one potentiometer. And this is the IDE of Arduino that I use. The version is 2.3.4 with dependency of Servo.h version 1.2.2 by Michael Marcus and Arduino, and Liquid Crystal I2C by Frank de Brabender. And this is the wiring diagram that I use. So there is one minimum system from Arduino. This is the minimum system of Arduino development board, and this is the LCD. We have the I2C here, so we connect it to SDA and SCL of Arduino, and then we have servo motors, and we have potentiometer here. So before we continue to the video, we will see my last presentation about servo motor theory first. Okay, I will explain about servo motor. Servo motor or servo refers to any closed-loop control system that operates using negative feedback. An example of a servo system is the cruise control in a car, which monitors the vehicle's speed and uses that feedback in a control circuit to adjust the accelerator, ensuring a consistent speed. In the case of RC servo, the output shaft position is continuously measured and fed back to an internal control circuit. The circuit adjusts the motor's current to maintain the desired position. This is some servo motor example. The price is from $9, $11, $12 like that, up to $42 or $43. The the type or the mark, can be high tech like that, and also this one is high tech, all of it is high tech. This one is parallax, and the price ranging also from $40 like that. We have some some example for servos, the types, the color, something like that. This is inside the servo motor. There is a gearbox like this with high torque, but the the RPM is so slow, and there is a potentiometer to serve as a position sensor. This is the central control circuit, and this is the DC motor with high speed and low torque. Okay, this is the real breakdown of servo motor. This is as we usually use DC motor. This is the position potentiometer, and this is the circuitry with a small microcontroller or a specialized servo IC. This is the gearbox, and this is the color scheme. As I said before, we can see that the color is mostly black, red, yellow, but this one is different: black, red, white, maybe. Okay, so this is the color scheme. This is the table below provide a summary of common color scheme encountered in electronics. This is for a mnemonic easy to remember. This color code associated with darkest color, usually black or brown, is usually connected to ground, and while red is usually connected to power. Okay, this is Futaba. If Futaba, we can black, red, white. If from GR, brown, red, orange. If high tech, we can have either black for ground, and for power we can red or brown, and control signal we can see yellow or white. And for the we can see that what we need to consider, and if we want to connect to servo motor, we need to always refer to the datasheet. Atung atung. And for the servo motor, we can see in here, if the on time is only 1 millisecond or 0.5 millisecond, the servo will move to 0 degrees. Okay, this is 20 millisecond or 50 hertz. And if we want to move the servo motor to the 90 degrees, the on time should be set into 5.5 millisecond with the same period of time, 20 millisecond. If we want to move the servo to 180 degrees, we should set the on time to 2 millisecond or 2.5 millisecond. According to the datasheet, we should refer to the datasheet. So this is a little bit theory about the servo motor. And because we will use the Arduino, not all pin of Arduino can be connected to servo to control the servo motor. So it should be in some of these pins. The pins that has infinity symbol like this one, pin 3, 5, 6, 9, 10, 11. Okay, that's from a little bit introduction about servo motor. Thank you so much. Okay, after we know about servo theory, I will show you the code that I write. This one is the code that I write. We have two libraries, and this is the setup for the LCD with the address of 0 hexadecimal of 27 to 7, and this is the setup. The LCD will print the servo motor and the servo attached to pin 9 with PWM, and this is the loop. We have LCD and then print nothing, or we can write this one display, and this one value. We have a variable of value analog rate is 0, and we have to map all the value to 0 with a maximum of 1023, and we have to map from 0 degree to 179 degree. Okay, and I will show you the video of this experiment. So the LCD always show the servo motor only like that. And this is the potential, if I turn the potential to right, the degree of motor servo will continue to move. Same with this one. Okay, that's what I can show you for this experiment. Thank you so much for your kind attention and see you in the next video.